Alright, so what we're about ready to do is the exact opposite of what we were doing. What we were doing is I gave you the sigma, and then you guys expanded it out and added everything together, right? We're going to do the opposite now, and the reason we're doing that is because it's going to be very helpful for what we need to do next class, is you need to know how to take a sequence and crunch it down into sigma notation. And so here's some steps that we're going to be using, so go ahead and write down these steps. So, when you guys are looking at this sigma notation thing, we're always going to be starting with the first term when we put it in sigma notation. That's what we will do. The only things that are going to be we have to discover and try and find out is what term are we going to go to, because a lot of times they're not going to tell you up front. And then we have to figure out the nth term formula. Good news is that part of it we've already know how to do. We did that last time. So first of all, we have to look at our sequence, and then we have to decide, okay, is this arithmetic or geometric? Then we use the appropriate formula, and once we got that formula, just put it here on the right. So you're halfway there. The next thing you have to do is determine what the upper limit and lower limit is. The lower limit I already told you is 1. So just to find out what the upper limit is, you'll see when we get there. What you have to do is they're going to give you the last number. So what we'll do is we'll plug that in for Tn, and then we'll solve for the n. And once you've done that, you'll know what term it is. And that's what goes on the top. So that was probably a lot for you to take in, but we're going to do a few examples. Let me go through an example really quick that I'm not going to ask you to write down, but just to watch so you can get a big picture view of what's coming up. So suppose that we have this sequence up here, and let's say I want to make it a series. So let's say we add all those together, 2, 4, 6, 8, all the way up to 54. And I want to put it in sigma notation. So the first thing we need to do is we need the nth term formula, so we need to decide what nth term formula to use. So it's arithmetic. You guys see it's going up by 2 every time. So since it's arithmetic, I'm going to use the T1 plus D formula. The first term is 2. The common difference is 2. After you've got your nth term formula, what we can do to find out what n it's going up to is using this method. What's the last term they give us here? Okay, now that's Tn. That's the nth term, the last one. However, I don't know what n is. What term is that? Is that the 20th term, the 40th term? What is that? Well, you can find that out by putting 54 right here for Tn and solving for n. And that'll tell you what term it is. And if you did that math, you would get 27. So what that tells me is that 54 is the 27th term. Okay? Now that I know what the upper limit is, it goes from the first term to the 27th term, and I know what the nth term formula is, I can write it in sigma notation. It goes from 1 to 27, and my nth term formula goes here. So we're working backwards. We're taking a sequence, or a series, and crunching it down into sigma notation. Let's do a few of these. Go ahead and write down number 1, please, and your direction. So I want to write this series in sigma notation. I'm starting with the first term, which is 1, and going up to 57, the last term, and it's going up by 4s, it looks like. So let's go ahead and start off. So the first step that I told you guys to write down is, first of all, we have to decide what is this. Is it arithmetic or geometric? It's arithmetic because it's being added by 4 every time. And that the whole reason we have to do step 1 is so we can do step 2, which is pick the right formula. So what's the arithmetic nth term formula? Okay, I'm gonna go and write the nth term formula out first, and then we'll plug the numbers in. So we're gonna go ahead and use that one and plug the numbers in that we need. So what is the D on this problem? And what is the T1? 1. So let me make a quick correction here. So there's our nth term formula. I'm not going to simplify it this time if you don't mind. I'll just leave it like that. So now step 3 is we need to figure out what the upper limit is, because we're basically done. I'm almost ready. I know the bottom is going to start with the first term. I told you when we do this, we're always just going to start with 1. We know the nth term formula, and that's what goes here. So I just need to figure out what's going up here. So I know my last term is. My last term is 57, but my question is, what term is that? Is it the 20th term? Is it the 100th term? What is it? Well, let's go ahead and figure it out. Here's how you do that. That's the term. That's your final term, Tn. So what's my final term that I'm trying to find out? It's 57. And so I want to figure out what n is that. What term is it? So we can just solve for n here. Let's do it. Distribute. Combine like terms there. We get minus 3. So I'm getting 60 equals 4n. And then by division, we get our final answer, which is n equals 15. So that tells you your upper limit's 15. And that's step 4, which is just to put everything where it goes. The n goes on the top, 15. That the max value it reaches, it goes to the 15th term. And we're always going to have 1 on the bottom for our purposes here. And then you can put the nth term on the right. Now just so you guys know, on your test, I might have the simplified version of the nth term where you distribute and combine like terms, but I'll leave that for now. Are there any questions about that? So let's do number 2. Now number 2, you guys can see it's not arithmetic. What's going on number 2 here? It's being multiplied by -4, so this is a geometric one. And therefore, we have to use a different nth term formula, which is this. And we know T1 is -2. And we know that R, well, how do we find R again? Let's do that on the side. You second term divided by the first term, which is -4. So it's -4. All right, now step 3. Correct. You take your last number, your last term, and you're going to replace that for Tn. That way we can figure out what n is. Now at this point, we might have some concerns because this is a little tricky to solve. It's nothing we haven't done before, but it is something that you've only seen done in this class. So we're going to have to think back maybe like a month ago. What do? You divide by the -2 first. And that's going to leave us with -1024 equals -4 to the n minus 1. This is all step 3, by the way. All right, but we're still not done. How do you solve for an exponent like that? It's logs. We got to go to logs. Ah, there's the moon. Aw. Yes, it's logs. All right, so I'm going to go ahead and change slides. Have you guys got it? Okay, here we go. Now this is what we have. I'm going to reverse the order. You'll see why in a second. 4 to the n minus 1 was equal to -1024. You do the left, right, middle trick that we talked about a while back. Log base what? What's the base? -4. And left, right is -1024 equals the middle, which is n minus 1. Now, just as a note here, we have to be smarter than our calculators. Our calculator's not going to understand how to do that thing on the left. It doesn't do negatives when you're doing logs. So we have to, it doesn't mean there's not an answer. It just means that given our calculator, which works in base 10, it's not going to understand negatives when we try to plug these other negatives in. So what we have to do is let's ignore the negatives when we use our calculator. So our calculator is not in base 4, by the way. It's in base 10, so what do?
You have to do log base 10 of 1024 divided by log base 10 of 4.
Yep. Log base 10 of 1024. Notice how I'm not making it negative, right? Because my calculator won't understand that. Over log base 10 of 4. That's the change of base formula. And if we did the change of base, what would we get? What is log 1024 divided by log 4? So 5 is the answer for that. And then all we have to do is add 1. And we get 6 equals n. And that's your upper limit. It's the 6th term. All right, so now we can take all of our information and put it in sigma notation. So what was the last? We found out that the highest term was the 6th term, and we always start at, and my nth term was -2, -4 to the n minus 1. So the geometric ones, you have to use logs to figure out what your n is. There is another way you can find out what n is, which would work, but we're going to stick with logs. I think that's the easiest one to review right now. Okay.